Hello, Mr. Victor. Good evening. Okay, so everybody meet Mr. Victor Ofoegbu. He's a software engineer with full stack software engineer, very important, with 7 years of experience building products that empower people to achieve more. With a unique background spanning product design and engineering, so which means it's a unicorn. He can do full stack, he can also do product design. He creates tools that are both powerful and intuitive. He has previously worked at companies like Staffbase, Contentful. Previously, yeah, Staffbase and Contentful. Victor now works with startups developing cutting-edge AI applications. He specializes with generative AI systems, design systems, and software architecture. He brings deep technical expertise with product-first knowledge. So what this means is he doesn't just know how to code, he knows how to build, how to design as well. That's powerful, and that is one of the reasons why we brought him to talk to us today, so you can see how to use these tools, whatever your stack is and whatever your skill set is, how to build products end to end, and not just um, write code only. So Mr. Victor will be talking to us about code acceleration, how to 10x development with GitHub Copilot and Cursor. Ladies and gentlemen, can we give a round of applause for Mr. Victor as he takes the center stage? Welcome, sir.
Yeah, thank you. Good afternoon, everybody. I'm really excited to be here. Actually, this is my first speaking experience, and if you know, as a developer, it's quite hard to do a lot of this. So, yeah, one reminder: if you're unmuted, you should actually mute so we don't get some holdbacks. Um, yeah, so I'll share my screen and begin the session. Wait, can you see my screen?
Yes, we can see your screen, sir.
Okay, great. So, yeah, the prompt is you building the future with AI. And so my name is Victor, like I said earlier. I have probably around 7 years of professional experience across a wide range of fields. Started as a product designer for a year or two and then transitioned into software engineering. So yeah, I would say I bring like a holistic view to most development processes. And today I'll be sharing with you how you can 10x your productivity with GitHub Copilot and Cursor. So I'm on the internet, on a lot of places, but right now you can actively get me on TikTok. So I respond to messages and put in our videos regularly. And yeah, let's talk about the overview. So this is actually a hands-on workshop, and we'll cover advanced techniques that will help you like compress your development cycles using GitHub Copilot and Cursor. From the name, Copilot is from GitHub, and Cursor is a company that builds the Cursor editor that is a fork of VS Code. And yeah, so the main topic for today is like agentic workflows and how to use agents to prompt, plan, and execute multi-file changes. And yeah, and then after that, we'll go through everyday use cases for developers. So yeah, this is pretty much the same. Just move to this. So what you won't learn from this session is how to build an app with one prompt. We see a lot of running jokes where people just say, like threaten the AI or like beg the LLM to do things right. And yeah, this is not what this session is about. This session is not exactly about vibe coding or building complexity that you don't understand. Just a disclaimer. So a quick note on vibe coding. Like we know, vibe coding is like abstracting thinking to an LLM through natural language, and the core idea of this sounds good. It feels good to kind of like use a language you use every day to communicate to like um, our computers. But there are a couple of downsides to this, right? And this term has been convoluted recently to mean a lot of things where like people pick up people push a lot of things to production that are not production grade, right? So a better term is AI assisted coding, which is like having a senior engineer on your shoulders. Now think about it. If you have a senior engineer like looking at your screen every day, what kind of questions would you ask? Would you say things like make this button pretty, or would you say things like how does this work, or how can we achieve this? So at the end of the day, is it's like a junior colleague that you have that knows quite a lot, probably knows a lot more than you do. So you are to work with these LLMs as a team, as a teammate, and then treat them as one. So we've seen really dumb mistakes as a result of vibe coding, like leaking API keys. I'm pretty much sure right now, if you type OpenAI underscore key, you would probably see someone stuck in there. And then this is because, of course, these are systems, they will break eventually. And when they do, the results can be really, really fatal. Um, we've seen instances where production databases have been deleted by MCP servers, and a lot of weird bugs in different places. And I will end by saying like vibe coding is great for experimenting, for weekend projects, and generally just prototypes, but it's bad for production apps because of the fact that you just do not understand the complexity you're building. And understanding complexity is important because when it breaks, you can know how to fix it or where to go to fix it. And as always, you would stand out by understanding how things work. There's never been a person that understood how things work and lost. So instead of yelling at cursor and like doing all sorts of hacks, you could take 5 minutes to understand what it is that you're building. And this skill is very important right now that we have a suite of tools that promise to give you production grade applications with just a prompt also. And we'll start by talking about what are AI agents. So AI agents are systems that leverage an AI model, in most cases an LLM, and has defined tools to interact with its environment in a perception, reasoning, action flow. So keyword perception, reasoning, action, because this is basically the way agent works. So if you look at this graph, this image here, you see there's a goal and there's a black box, which is the whole React framework where the LLM observes, reasons, and acts, and does that over and over again till it achieves a goal. So the perception layer is like the data source, the reasoning layer is an LLM, and the action layer is a tool. So as an example, I'll show you a really quick demo of this. I have a lot of stuff open because I need to show this. So yeah, so let's take, for instance, this block of code. So what is this doing? This is basically like a fetch request to a completion endpoint that is going to return server-side events or HTTP streams. And this on its own can work, right? You just call it from wherever you need this. So in our case, we need it here where we fetch the request. But we could actually improve this by saying no, not this one. Just a second. Actually, when you have a lot of tabs open, it becomes really, really confusing. Hmm. No. Let's see. So for this demo, I prepared a lot of open VS Code windows already. But yeah, I think you can use this one. Let's use this one. And let's open a new chat. So what we're trying to do is, let's assume you want to add a new method to this, a new method, maybe to cancel an HTTP screen or a web to abort the request. Then you would need to define a function, and then you would need to like constantly define functions. But then you can put this in a class and make it more of a great design pattern. So let's say we want to convert this to like a class, a chat service class that has methods like fetch complete. Now we would prompt this by including the chat service and say, I'm planning on adding new methods, and I want to improve this by making chat service a class. Then I could say, of course, I want it to be a singleton because we don't want to instantiate it every time. And the method should be static. Then let's look here. You see, it's kind of planning the next moves. And then you see that there's a loop going on. So it does some thinking, it goes back, it checks, it tries to act, it's gathering information now, and you see that it's gathered information for that round of reacting, and then it tries to gather more information, and then it goes through this loop of trying to find more information and find the best tools to use to solve your problem until it arrives at that problem. So you see now we edited some code, and it's going to go back and check, does this look good? It's going to go back and observe again and try to create a plan and solve the problem. So this mimics how humans solve problems, and this is the core of an agentic system. There's there has to be a feedback loop between the internal system and the external world. So for a coding agent like Cursor, the perception layer will be a storage of embeddings in your code base. So whenever you have a new code base, if you go here and you take a look at indexing and docs, you would see that so this is indexed. What this means is that all our code base has been converted to an embedding and stored in a vector database, so that whenever there's a new query from us or whenever there's like a question, we know exactly where to find this. So if you're familiar with tokens and embeddings and vector database and similarity search and cosine similarity, you kind of understand how this works. And then we have the reasoning layer, which is the LLM. And like you can see here, we can choose any LLM we want for the job. Like here you can say I use Gemini 2.5 Pro. I can decide to use any LLM to show that this system is kind of like detachable. And then we have the action layer, which are tools that the agents use to perform actions. And in most cases, there's a web search tool, there's a read file tool, there's an edit file tool, and there's also a tool to run command in like the terminal. And this loop is continued till the goal is achieved. So just a primer on how agents work. And let's talk about a context quickly. So the context is like the basic working memory of an LLM. So for instance, here in this request, I included the chat service here. This is context to the LLM, and a lot of other stuff that the LLM finds that is similar in the vector database. It puts it together as context and sends it to the LLM. So for coding agents, it can be your prompt, your selected files, or an image. And it's also important to note that different models have different context lengths, and this should inform your choice of models. So for instance, if you want to do like a huge refactoring, then you should know that you should look for a model with a larger context window, maybe like Gemini or Grok, for example. And then there's some common agentic coding patterns. We have like tab completion that we can see here. Now let's accept this. And let's try to add a new method, for example. This is like the tab pattern. And there's the chat mode, which is what we have here. There's the standalone agent mode, which is only available in Cursor for now. So when in this view, you can only kind of like interact with one agent at once. But with the agent view, you can have simultaneous agents going along your business, possibly modifying the same files. So it's important for us to keep notes of this. So for instance, I can have an agent do something here, I can have a new one, and they can go on concurrently. And yeah, and then we have the terminal focus mode, which we see in tools like Cloud Code, Codex, and Gemini. So some general tips for AI-assisted coding. First things first, you want to break down your tasks into smaller, meaningful steps. Now, the title of this workshop is Accelerating Your Development Pace 10x, but you have to actually go slow to go fast. You have to break down your tasks into smaller, approachable steps so that the LLM can plan. LLMs are good at planning. The LLM can plan and go from there. So, for instance, here's an example: build. No, sorry. So, for instance, here's an example: build a user authentication system for my app. Do it right. Now, this is really, really vague, right? And this is where we see a lot of mistakes for in LLMs. And one point to note about LLMs is that they are non-deterministic. What this means is that every time you send the same request, you get a different response because there's a concept known as sampling, which is an LLM determining how it responds to your question. So it can be different based on the temperature, based on the top K, and other parameters that we can customize. So a better way to write this would be first create a login form component with email and password fields, then add form validation, then implement the API call to the auth endpoint and handle JWT token, and finally add protected route logic. Now, if you were a junior developer, which of this would be more easier for you to reason about, right? The second, right? So this is step number one. And step number two is to describe the task specifically. You want to talk about the files you want it to create, the classes you want it to create, and be more specific because there's really no cost for being specific. Um, the token windows are really small for text. For instance, you can add even a full PDF to some models, and they will take it because they have larger context size. So be generous with words and describe the task specifically, so the API, so the LLM can like understand. So in this case, you say like add a payment feature, make no mistakes. Now, this really doesn't do anything for you when prompting an LLM. Like it doesn't work like that. So a better prompts can be, what are the steps to implement Stripe payment integration? This didn't even mention Stripe. And then using their latest SDKs, reference this guide at some website. Also search for the web for latest Stripe API best practices. Now, I'll pause and give you this tip, right? So for instance, if you've worked with Tailwind CSS test, the migration to V4, which is really, really, really a pain to work with because the documentation is not clear and all that. So in most cases, if you try to bootstrap a new project from scratch with maybe an agent and you tell it to build like a Tailwind config, it's going to like build on based on V3 because it's the cutoff length for the LLM is way too far before the V4 was released. In that case, you can really just go here and say Tailwind CSS V4. You could copy this and paste it in the LLM. And it could use this as context. It's going to use the website to search the web. You could say read the docs and implement the changes, for example. So this is in my opinion, much better than telling it to like rely on its internal knowledge. So you could actually add links to your prompt. And the third tip is to plan properly, right? Use plan mode in Cursor. Now, I would say as a developer, you should outsource majorly the writing of code, right? The thinking, you can bounce ideas with an LLM, but you shouldn't outsource the thinking because the thinking is the core idea. And if you don't have the core idea, then you have nothing, right? So instead of jumping straight into coding without planning, then realizing halfway through the architecture that it doesn't support the requirements, you want to take time and plan. For instance, in Cursor, there's a plan mode in Cursor. So let's say I want to do something. Let's say, can you rewrite this whole project in JavaScript and not TypeScript? Sorry, and not TypeScript. So there's a plan mode, right? Which when you toggle it, it's not just going to go into writing code. It's going to take time and ask you questions, ask you of some tips like what version of JavaScript do you want to use? For example, what environments would you be in? Would you be on the browser? Would you be on like an edge? Would you be on the back end? It's going to ask you all those questions. So see, it's trying to clarify. And for instance, if I answer this question with a yes, which is like you shouldn't do, but we don't have time, so we just do that. Then it's going to generate a plan for you, right? Just waiting a second. I mean, if you work with LLMs a lot, you will get frustrated by this. Sometimes they take really, really long. But then I believe we take longer to think. Humans take longer. So yeah, so it generates a plan for you, right? And the idea of generating this plan is so you be more granular with your requirements. It tells you what files it wants to convert. It tells you how it's going to convert them. And at the end, it gives you like a to-do. And if you're okay with this plan, then you can go ahead and build. And it's way, way, way better than saying build me. It's way, way better than this, right? For example, before it would just go straight into coding and without understanding your requirements. So take advantage of plan mode, actually. And the fourth tip is review generated code line by line. Now, this could feel like a lot, but you still want to do it because if you wrote the code from scratch, you were going to like basically review it line by line. And the reason you want to review it line by line is that LLMs are known to be correct even when they are wrong. So LLM is like a good liar. Like they convince you that's the truth, meanwhile it's a lie. For instance, you could tell it generate or write a class, and then it could write code that looks correct when you look at it, but there's most likely something wrong somewhere, but you don't know unless you go through it line by line. By just looking at maybe the class and the function, you could say, okay, everything is correct. So it's like you have a junior developer, right, that knows a lot. So every time you suggest code, you have to review it yourself. And you have to also use source control extensively because sometimes you could tell an LLM to do something and then it goes to do another thing and then you lose all of your changes. So you have to always commit in milestones, and then you can use standard files to add guardrails to agents. For instance, there's the cursor/commands, which you can add commands to cursor, and then you have the cursor rules where you can define rules that you want to apply to your code base and in some cases to your whole projects on your machine. So yeah, let's start with the labs. And I don't know, should we take questions first or maybe go ahead with the labs? Not exactly sure.
Mm,
Um, yeah,
okay, guys, if you have your question, post it in the Q&A, and then Victor is going to answer it as he teaches.
yeah,
So go on,
that's
sir.
yeah, that's a good point. Okay, so let's start with the first lab, which is like writing code. So I try to arrange this um really well, but there might also be some um okay, so let's start from here. There's this annoying. Okay, I guess we can start from here. So the task is that we want to write a completion endpoint. So this is a Node.js application with Hono. If you don't know what Hono is, it's a backend framework, a very lightweight backend framework. And what we want to do is expose an endpoint for completions. So what this means is that we want an endpoint that we can call from anywhere, front end, that's going to stream requests directly from OpenAI. So if you look here, you can see that this is what we require. We require prompt, messages, and model. So I have this setup here. The prompt, the model, the messages. Let's take these ones out because they don't matter at this point. So the task here is to prompt this LLM to kind of like implement this. So this is just a stub, and we're just doing basic stuff here. You see, this just like we're not doing an actual request to OpenAI. So this is what we want to do now. So from all the lessons and all the tips we've had, we know first we want to break down these tasks into the smallest possible parts. So I'll also note that I'm using a mix of Cursor and GitHub Copilot, depending on the one you're using. And I also forgot to mention that GitHub Copilot, Cursor has a $20 per month subscription. So if you are not already using it, you might have to pay, except you're in the free plan, of course. So yeah, let's say let's break this down. So first, we could say we want to introduce an OpenAI service here. So and that makes sense because we always want to separate consent. And yeah, let's try to prompt the LLM. So let's say I want to implement a completion endpoint that streams requests and response from the OpenAI API. The let's say the completion endpoint is already defined, but it's stub. So I want to implement it. I want to create an OpenAI service that I can use a method from, preferably, let's call it generate, let's call it generate completion. So this is going to be a method on the OpenAI service class. And what else could we add as context? I feel like this is good enough context, right? Or if we wanted to be really specific, we could go to the web and find the completion endpoints in OpenAI completion endpoint, and then paste this doc here and say, here's the OpenAI docs for reference. And then let's watch what it does. So we're going to do a lot of waiting when this is happening. Okay, so it's planning the tools to call, and it's implementing already. So it created 5 to-dos. So like I mentioned earlier, agents have tools. So there's a tool to read a file. There's a tool to edit code. There's a tool to search the web. There's a tool to search for code in your code base. So it's going to use all these tools to do the right thing when needed. So it seems like it did. So you see, because we mentioned that we wanted to create an OpenAI service, it knows that you should put it in the services folder, right? And then you see, this is what it looks like. And then how did you know that this is the endpoint? Because he looked at the docs, he read the docs, and then he knows exactly the most up-to-date version of this. So let me also show you something. In Cursor, you can also have access to the docs. I forget how that's done. Docs of um, some major frameworks. So, for instance, if you're a .NET developer, you can use this to kind of like get um, response directly from the docs and not rely on the cut-off knowledge from the LLM. That's just something neat that Cursor provides. So it seems like it's done and it's trying to run build. So this is trying to use the terminal tool and it's asking should you build or not. I'll just keep it for now. And then let's look at the code that it generates. Most times I like to look at it in the diff view, because I can kind of see the changes it made there. So let's start from here. First, we imported this OpenAI service, and you see that it's calling it here OpenAI service.generate completion, and if it's passing kind of parameters inside of it, it sets the new header and then just returns the response like that. And if you look inside of the OpenAI service, you see that it's just a basic class with static methods, and then there's a generate completion that is calling the OpenAI endpoint. So that's the first lab that we were going to look at. And the lesson here is that you always want to include as much context as needed for the tags, and be more specific, break down the tags, and actually be specific in like what you wanted to create, the name of the classes, the name of the files, and so on. Now, it took a little more time to kind of like prompt this, right? But then, like, imagine you didn't do this, then probably it doesn't create a service. And then you know that, okay, you need a service, and then you tell it to create a service. There's a lot of back and forth when you just don't plan properly. So that's it for the first um, lab. I was going to check if it works, but I mean, it really doesn't matter if it works or not, right? So yeah, the second one is reading and studying code bases. So the task is to study the GitHub Codex CLI. So Codex is like a CLI like Cloud Code, which is developed by OpenAI. Yes. Sorry, I made a mistake. I said GitHub Codex is developed by OpenAI, right? I don't know. I mean, let's confirm. Codex, yeah, is developed by OpenAI. Yeah. Okay. So let's use cursor in ask mode to study and understand large code base. So for instance, let's find this code base called Codex. Yeah, so this one, and the repository is here. Codex. Yeah, so this repository. So I basically just cloned it to here. So let's use cursor in ask mode to kind of learn more about this project. So in ask mode, there's no code generated. It's just conversations with the LLM. So we could start by saying, um, give me a brief overview of this code base. Cover the most interesting and relevant parts, and leave out, I mean, this tautology in a lot of ways. So the most interesting and relevant parts, what else would we want to know? What languages is it written in? And then provide me with a plan to learn and understand this code base. And then because it's ask mode, it doesn't use any tools. It's just going to read the file and provide a plan for you. So I see there's a question in the chat. Okay, where would this recording be available? I think there's going to be a link shared after the session. Okay, so this is what it generates. Like Codex is a CLI coding agent from OpenAI. And then it tells you like the primary language is in Rust, 90% of the code base. And the main implementation is Codex RS. And then there's a JavaScript bridge. And then there's Python and there's Nix for system configuration. And then it tells you the core business logic, right? And gives you an overview of this code base, and then goes ahead to tell you parts that you can start from. So you can start from the getting started, and you can go from this to kind of understanding the main concepts of this code base. So that's the second use case. You can use LLM to quickly understand parts. Now, something else you can do is kind of say, can you generate a mermaid diagram of the code base from this explanation? So mermaid is like what's it called? A diagramming, a programmatic diagramming framework, right? Where you can like have this kind of flows and charts through code. So yeah, it generates this for us. We can see it even if it messes up the kind of like accessibility, but you can see that you can read this and know, okay, this is how the parts of this code base come together. So that's the for the second use case, studying large code bases and understanding code bases. So for instance, you join a new company, you need to be onboarded in the company really quick. You can use an LLM to kind of understand parts of the code base. Yeah. So the third one is reviewing PRs. So if you work in a team where there's a lot of a team that moves fast, there's a lot of PRs coming in, then you actually need to include AI in your peer reviews, right? So there are many ways to do this. One of them is one that I fortunately do not have access to, and it's GitHub Copilot on what's it called, on github.com. So here where we have reviewers, you would ideally add GitHub Copilot, and then it will tell you like in comments what are the problems with this PR and what you need to fix. So let's go to VS Code and show this. First of all, let's keep this. And let's select this method, for example, hit Command Shift P and say review, let's say ask GitHub Copilot review. And then it's going to review this part of the code. And if there's a problem with it, it's going to generate kind of comments and tell you things that you need to fix. So right now it's reading the code and trying to like see if it's good or not. This is also interesting for when you need to, when you're not sure about a particular logic that you have. So maybe you're moving fast in the hackathon, and then you think that this there's a bug here. So you just select all the code and review and have the LLM tell you what is not working there. Yeah, so I'll proceed to the last lab, which is planning features and refactoring. So the plan mode is really, really underrated. It's an underrated feature from Cursor. Was launched probably like 2 months ago. And I have a use case for that here, which is one of my side projects, Job Quest. You can actually, for instance, see it here. Yep. So this is more like a job search tool. And what we're going to do is so I wrote this in Next.js like a year ago, and I just decided I didn't like Next.js anymore because there was just a lot of back and forth revalidations, caching, and all that stuff was becoming annoying really, really quickly. So I decided that okay, I want to refactor this whole code base. This is a really large code base. It has probably around um more than 500 commits. So 514 commits. And this is a really, really large code base. And the idea is that I want to move this whole thing out of Next.js. How do I do it? And this is where the plan mode comes in. You have a really big feature that you want to implement, but you don't know exactly how to go about it. So you plan with Cursor. So you see, I'd say I have this project in Next.js, but I got fed up with the library or the framework, and I want to write it in vanilla React with, of course, TypeScript, with vanilla React and React router DOM plus React query. And then it's going to ask me some questions based on the code base, and it's going to generate a plan. And when it generates the plan, I'm going to try to have it run the plan, which is going to like be a lot because, like I said, this code base is really, really large. But how else would you do this? Would you just tell it to do all that in one go, and that's probably going to fail. Like all the time is going to fail. I'm really sure about that. So now it kind of like asks us more questions based on this. It's asking us, so this is an exciting project migrating from framework like Next.js to more vanilla React setup with React Router and React Query, blah, 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 blah. So this is a large migration. I propose we start by creating a new application and migrating core features like viewing the job list and blah, blah, blah. And the idea here is that because the LLM has a very large memory context, much larger than ours, it can know the best approach to use depending on the size of the code base. So you can see here, it suggests that we should create an entirely different project inside of here and start moving the logic gradually, which in a lot of ways is the best approach to take, right? So we can say, yes, I like the idea of starting a totally different project inside. And then what other question does it ask us? It says, uses Next.js API routes and server actions for backend logic. For the new React application, what's your preferred approach for the backend? So in my opinion, I would say I want a Ono backend inside a Docker container, for example. And then based on this, it's going to generate a plan for us. And we'll see how comprehensive that plan is going to be. Okay, where's the plan? Okay, great. So yeah, it breaks it into different phases. The first phase is the project scaffolding. We're going to scaffold a new project inside of here. And then there's the backend setup with Hono and Docker. And there's the front end setup. And then we start moving the routes. And then we start migrating features by feature. And then it creates this whole um, task list for us, right? And then if we click on build, it's going to go one after the other and start executing these steps. And the good thing about this is that this is mindfully using AI. This is AI assisted coding and not necessarily vibe coding. If this was vibe coding, I would say migrate this whole app to React plus React query. Then I say, make no mistakes, do it right this time. And see, doesn't have any info. It really just doesn't help, basically. So yeah, this is the last lab. And then in conclusion, AI coding agents are transforming how we build software. But there are tools that amplify your skills and not replace your judgment. Like I said earlier, you have to keep your judgment and your ideas and your reasoning. You shouldn't abstract, you shouldn't outsource that part, right? So the key to 10x productivity isn't just using AI, it's using it strategically, breaking down the problems, being more specific with context, and planning before coding, and always reviewing what's generated. So if you master these patterns and commit often, you ship features faster and maintain while maintaining the code quality. So yeah, this is it for this session, and I love questions and discussions. If there's anything that's like maybe confusing or contradicting to what you know, it would be nice to like maybe drop it in the comments or ask questions if you um deem fit. So this is it for now. Thank you guys for listening. I'll stop sharing my screen now. Can you guys hear me?